Okay, in this video we'll finish section 3.4. We've been working on graphing polynomial functions. What we've been doing is we've been taking a formula for a polynomial and we've been sketching its graph based on x-intercepts and y-intercepts and in behavior and a sign diagram. What we're doing now is we're turning the problem around. We're doing the problem in reverse. Now we're given the graph and we're asked to find a formula for the function. And so let's go ahead and get started. We can call this function f of x if we like. And since there's an x-intercept at -5, then there must be a factor of x plus 5. And since there's an x-intercept at 3, there must be a factor x minus 3. We also need to look at the behavior at each of the x-intercepts. At x equals 3, the behavior is a bounce, and so we know that that means that the factor has degree 2. If we look back at the x-intercept at -5, that behavior is crossing the x-axis, and so that exponent, so the exponent on that factor is just 1, and so we can leave that. There's one more thing we need to account for. It's the y-intercept at 0, 9, and the way we're going to do that is we're going to have a factor of a constant factor a, that will stretch or compress the graph through the point 0, 9 without changing where the x-intercepts occur. So this is a good answer already in the first step. It's just missing one thing. We need to go ahead and figure out what the value of a is. And so to get a, we're going to plug in the point 0, 9. To get a, plug in x equals 0 and y equals 9 and solve for a. So f of x is the same as y. It gets replaced by 9. A times 0 plus 5 times 0 minus 3 squared. And then just solve for a. 9 equals a times 5. 0 plus 5 is 5. -3 squared is 9. So this is 45 times a is equal to 9. 45 times a is equal to 9. If we divide both sides by a and simplify, well, we get 9 over 45, and when we simplify that, we get 1/5. So we're ready to write our answer. We can write f of x is equal to 1/5 x plus 5 x minus 3 squared. And there we have it. We can go back and check our answer. We can verify that that this function really does pass through these 3 points. So we can plug in x equals -5 and get 0. We can plug in 3 and get 0. We can plug in 0 for x and get 9. And you should check and see that that really works. Okay, well, let's do one more like this, and then that'll be enough. So this one looks pretty similar. It's the same idea. Let's call the function f of x. And let's go ahead and start with the stretch factor a to account for the point at 0, 2. And then let's have a factor of x plus 1 to account for the 0 at -1. Notice it's a cross, and so the exponent is going to be 1. And then there's a factor x minus 1, which goes with the x-intercept at +1. What's the behavior there? That's not a cross or a bounce. That's the wiggle that indicates exponent of 3. Let's plug in x equals 0, y equals 2, and solve for a. So we'll have 2 equals a times 0 plus 1 times 0 minus 1 cubed. 2 equals a times, well, this is just 1, and then this is negative 1 cubed, which is negative 1. So 1 times negative 1 is negative 1. That tells us that a is going to be negative 2. And so we can write our answer. We can write f of x is equal to negative 2 times x plus 1 times x minus 1 cubed.